Okay, now you know everything. A thin disk is saying that one. Already we have found out field, no? Now similarly it's saying thin disk. Okay, carry on with the mathematics. So what is it? This what will be the sigma? No, it will be m by pi r square. Area density is what we define. Get into the mathematics. Today you just focus on calculating potential shape bodies. Tomorrow I'll come with more conservation of mechanical energy problems. Because once we know potential, I think we can manage. Okay, no. Again, the what is the method? I will go for a ring. Let me take this a ring R. Okay, what is the width of this dr? Mass of this be dm. What is the potential at point P due to this? First, what is the dm? Sigma into 2 pi r dr. I'll write all the terms here because you have to. Initial, these are assumptions, no? 2 pi r dr. And now, what is the potential at point P only due to elemental ring? What is this green color one? Elemental ring it is. So therefore, potential at that point will be dv is equal to minus g dm. Let me take this is x. This is smaller. Oh, so many are there. I think we can write it. This is a. I think I made let the radius of that elemental ring be smaller. X is the distance on the axis. Let me write that as a. What is a is equal to g into first dm sigma 2 pi r dr. A is what? Root of r square plus x square. So this, let me put it, minus of 2 pi g sigma r dr root of r square plus x square. Now what to do with this? I'll take help of the geometry. Tan theta, what you can write tan theta? R by x. Or instead of this, what happen? Let r square plus x square, let it be equal to say some p. Let me assume that one. Let r square plus x square, let it be equal to say some p square. Now differentiate this. What is a constant here? X is a constant, no? X is a fixed value. R is variable. R will be variable from 0 to capital R. So if I differentiate, this will be 2r dr. This will be 0 is equal to 2p dp. So in place of dr, what we can write it as dp. Now let me substitute this. dv is equal to minus 2 pi g sigma. R what to write? So keep it here. Now rdr is needed. No, rdr we have to replace. So this will become pdp. We will keep it here. No, root of r square plus x square. I think this will become only p. No. So this will become minus 2 pi g sigma dp. I will integrate now. Though no integration, I think you know the substitution type. So this will be 0 to p. Or don't put limit, just integrate. So this will become dv is equal to minus 2 pi v is equal to 2 pi g sigma p. What is p? Root of r square plus x square. What we assumed it. Now you're going to bring the limit. What is the limit? 0 to capital R. X is a constant. Small r is variable here. So what is the potential? No, the equation will come minus 2 pi g sigma root of r square plus x square minus x, or this will be there's a potential on the axis of the disk. That one I think you can remember, very simplified formula. Put x equal to 0. Put x equal to 0. You'll get potential at the center at point O. This is on the axis. This is on the axis. What is the potential? Will be 2 pi g into sigma minus r, or 2 pi g sigma. Sigma is what? M by pi r square 2 g m by r. There's a potential at the center of the disk. Got the basic idea? For several bodies, you can put it. So our final answer will be this is where at center of the disk. Now, like this, several bodies are there. Now, you go back. Already we know gravitational field strength due to this. No, can we bring from this potential that gravitational field etc. We have one more relation between E and V bar, gravitational field and gravitational potential. I'll proceed with the point mass. What is the field strength at point? What is the formula? Minus gm by r square. What is the formula for potential? Minus gm by r. Let me differentiate this dv. If I differentiate this dv, what do I get? We'll see it. Minus gm by r square into dr. No. So what is dv by dr? dv by dr is equal to gm by r square. So finally dv by dr, what you can write? Minus c. So there's a one relationship between what now? the field strength and the potential. Sir, how you can bring? Sir, I didn't do anything. I just took point mass. I know the field strength due to point mass. I know potential. Then I'll differentiate this potential dV by dr. I'll differentiate with respect to r. Finally, what happened? I got relationship between what? Between the potential and the gravitational field strength. And what is this dV by dr? It's called like a gradient. The gradient of potential is nothing but will be the gravitational field. So what is the relationship? In the book, what happened? They're given like this: E bar equal to minus dou V by dou R. What do you mean by dou? Instead of, if you're getting confusion, I'll write dV only. There's a difference. There's a difference between dV by dr, dou V by dou R. Dou Montalban, it's like a gradient, it is called as. So let me stick on to the basic definition. For our convenience, let's not change the basic core idea. It's called like a gradient of V. Or a simple thing, it's called like a minus of grad of V. Or it's called as a delta V. This delta called as gradient. Let's take it out again. Change you'll come to know. What is a gradient? Change only. That one. So what is the x component? If you know potential, differentiate with respect to x. You'll get the x component of field. If you know potential, differentiate with respect to y. If you know potential, differentiate with respect to z. You'll get the z component of field. Like this, all they are interrelated. So therefore, what is the expansion of this will be? E bar should be equal to what? dv by dx I cap dv by dy j cap. Okay, this is the expression for gravitational field strength. So like this, the potential and field strength are related. Sir, for only point mass? No, for any body. Sir, are you true? How you can say that one? Because again, you differentiate this, you differentiate this equation. You differentiate this. If you differentiate, what you'll get? You'll get the field strength due to the disk. Sir, is it like that? Yes. So now what happened? You have alternatives. What is that? If you know field strength, you'll get the potential. If you know potential, you get the field strength. So let me uh, take you back. So that one. So let's start with the disk. That one. Already we know potential field. Let me verify it. This is a disk of mass m and radius r. What is the potential at this point? 2 pi. Okay, where is it? 2 pi g sigma will agree. So let me differentiate this what with respect to x, not with respect to r, because on the axis you are finding out the field strength here. So dv by dx. This should be equal to how much? 1 by 2x minus 1. So this should be equal to what? Minus of dv by dx. So 2 pi g sigma. So this is what finally equal to E, no? Look at, is it that field due to disk on the axis? Gravitational field on the axis of the disk. If you know potential, you get the field. Or if you know field, you'll get the potential. You should know how to integrate that limits here. Getting this one? So therefore, this advantage. So whenever in exams, no, so you should take help of this advantage here. It means if you remember any one quantity, field or potential for any one body, that is enough. You can bring the other one. So just work out. So we're all now you go for the sphere, shell. We know already field, no? Yes, you can bring the potential. But so like a okay, now you say you potentially is there. Okay, you shown how to bring the field. So what about the field? If you know how to bring the potential, I'll take help of the same formula. E bar equal to minus dou v by dou r. No? This you are going to write it as E bar dot delta bar. This formula is when if you know potential, differentiate, you'll get the field. If you know